Good afternoon, guys. So just keep your calculators, books, and pens ready. Today we are going to solve some of the problems. Okay. Okay. Shall we start then?
Yes, sir.
Okay. So this particular problem is important for your internals. So kindly concentrate. Okay. So the piston cylinder machine contains a fluid system which passes through a complete cycle of 4 processes. So there is a cycle which consists of how many processes? It consists of 4 processes. Okay. During a cycle, the sum of heat transfer is equal to 1 minus 170 kilojoules. Okay. That means what he has given? He has given the total heat output from the system. The system completes 100 cycles per minute. That means 100 cycles per minute the system is completing its cycles. Complete the following table. That's all he says. So A to B is B to C, C to D, and D to A. These are the 4 processes which he was talking about. So these are the 4 processes from A to B, B to C, C to D, and D to A. So in some of the processes, the value of Q is given, and value of W is being asked us to calculate. So vice versa. So different values are given, different values you need to calculate through the concepts of the first law of thermodynamics. So before I start the problem, let us just recall the first law of thermodynamics, what it says. First law of thermodynamics for a cyclic process is what? Anyone? First law of thermodynamics for a cyclic process. How do I apply my first law? The cyclic integral of Kf is equals to cyclic integral of W. So that is the first law applied to a cyclic process. If I apply just for a process, then it is dK is equals to du plus dW. In the precisation, I can say it is dE plus dW if kinetic and potential energies are neglected, as we have discussed in the last class. So this is the application of the first law for the cyclic and the non-cyclic processes. Okay. Now what we shall do is now applying the first law for the above processes. For the above process, we shall apply the first law now. Okay. Now consider the process A to B. What R is given? K is given. How much is the value of K? 0. W is given, which is 2170, and he has asked us to calculate the value of DE. Now, if I apply the first law here for the process A to B, it would be Q is equals to delta E plus W. Okay, so the value of Q is 0, delta E that you have to calculate, plus the value of W is being given as 2170. Now, can I calculate the value of delta E from this? What is the value of delta E?
minus 217.
Okay, minus 2170. The unit remains same, so it is kilojoules per minute. Now, next, going further. So as soon as I get a value, which is minus 2170, update it back into the table so it would be convenient. So it is minus 2170 kilojoules, which I have updated it back. Now I will deal about the process B to C. In the process B to C, what all is given? The value of Q is given, which is positive 21,000. The value of W is being given, that is 0. And the value of delta E, again, we are supposed to calculate. Again, use the same expression. K is equals to delta E plus W, where K was 21,000. That is equals to delta E you're supposed to calculate, plus W is 0. So here, the value of delta E is how much? Kilojoules per
21.
minute. Okay. Now, by just looking at these processes, the values given, can you name which process could be A to B? Suspect. That's it. There is no relevance for the problem, just for our understanding and learning the subject. So, can you judge which process could be A to B and B to C? Can you?
So A to B is adiabatic process.
A to B is what? Adiabatic.
Adiabatic.
Okay. Why it is adiabatic?
So heat transfer is zero there.
Excellent. Very good. Now, here
Sir, B
the
to
suspect process could be, what is the suspect process here?
isochoric. Work is 0, sir.
Very good. Very good, man. I'm happy. So this is a isochoric process. Why? Because the work done is zero. It is not required for the problem, just for our understanding. We should move further. So have I updated it back to the table? No. So delta E for the process B to C is 21,000. Fine. I have updated it back. Next, I have to go for the process now C to D. So C to D, what is being given? Minus 22,100 is the kev value. Kev is equals to minus 2,100. Fine. And the value of W is not given. The value of W is not given. We have to calculate. And the value of delta E is minus 36,000. So the value of delta E is minus 36,000. Just to confirm, 36,600. So it is 36,600. The value is given. Same apply the first law, which is Q is equals to delta E plus W. Q Q is minus 2100, that is equals to delta E, which is minus 36,600 plus the value of W we need to calculate. Just calculate and give me the value of W.
$34,500.
34,000.
500.
So 500 is the value. 34,500 kilojoules per minute is the value. That's great. So next, shall I update it back? So it's 34,500 is the calculated value. All right. So for the process D to A, if you observe, nothing is given. Even the value of Q is not given. Even the value of W is not given. Even the value of delta E is not given. So how do I find out it? Let's look back into the question. So in the question, he has mentioned that during the cycle, the sum of all the heat transversers minus 170. That means the sum of curve, all this curve is equal to the value of minus 170. So I'm using that in order to calculate the value of curve of dA. So how do I do it? Just observe it. So sigma curve of a whole cycle is equal to minus 170 kilojoules. This is the value given in the problem. Okay. In order to complete this many cycles, so how many cycles are it is undergoing 100 cycles per minute, correct? So 170 kilojoules in 100 cycles, then you can just multiply the things to complete 100 cycles per minute. To complete 100 cycles, 100 cycles per minute. So what is the value of kf cycle is equal to minus 170 kilojoules into 100 cycles per minute. So this is the value is minus 1700 kilojoules per minute. So remember, do not forget to multiply it by 100 since the number of cycles is being given as 100. So this is the value of your sigma curve of a cycle. Now, what is that sigma q mean? Sigma q of a cycle is nothing but curve from A to B plus curve from B to C.
So
plus
delta E is given, sir. 100.
what man? What is given? Yes, Lucky. Any problem? Lucky, are you there?
Yes, I am there.
What's the problem? You interrupted in between.
Nothing, sir. Yeah, network problem.
Okay, fine.
Okay.
So that is the thing. So sigma cycle is nothing but QA to B plus QB to C plus QC to D plus K T to A. So this is what the sigma Q of a cycle means, right? That means this particular value, you know, that is minus 17,000 kilojoules per minute. QA to B, I think you have calculated. How many of you know the value? Man? Every time I have to look, just take a screenshot, man. Can help me with the values while substituting it. Okay. Now, what is the value of QA to B?
0.
Minus 2.
0. Okay. Plus QB to C.
21,000.
So it's 21,000. QC to D.
Minus 2,100.
2,100 plus Q D to A. I think this is the thing you have to calculate, right? So this is the only thing which is left over in the equation, you can think you can calculate it very easily. So what is the value of Q d to A, guys?
Thousand 900.
1000
900.
positive.
Yes, sir.
Okay. So 1900 kilojoules per minute. Is the value correct? Just check with other people.
Yes, sir.
Yes, sir.
Okay. Next, I will just update this back. So here it is 1900. Now, I can use one property in order to calculate the value of delta E d to A. So I'll just state what is that property is. Okay. That property which I'm using is now the cyclic integral of a property is always zero. You can write the statement, the cyclic integral of a property is always zero. So the cyclic integral of a property is always zero. So that is what you have learned. And so you have proved that the energy to be a property of a system. That's why the cyclic integral of T is always zero. What does it mean? Cyclic integral of T is zero in the sense E A to B plus E B to C plus E C to D plus E D to A. The cumulative value of all this is always zero. That is what he is meant. Clear? So given the values, whichever is known, I think this part is unknown, this fellow. So you need to calculate him. So give me the values of the rest of the things. What is this? Delta E. Yes. Give me the values.
Minus 2170.
Minus
2170.
2170 and this delta E B to C
21,000, sir.
plus 21,000 delta E C to D
Minus 36,600.
minus 36,600. Okay, plus
Yeah.
delta E D to A have to be calculated. So give me the value D to A
17,770.
17,770. Huh? Okay, so this is kilojoules per minute. So I will update this back again here. Okay. So this was 1900, right? And this is, what is the value of W? Okay, W I need to calculate. What is the value of delta E? Yeah, just 17,000 something you said, no? 17,000?
17,770.
17,770. Again, see, if you look at the process D to A, you can apply your first law to calculate the value of W, is it? Q is equals to W plus E that you can use for the process D to A. So for the process D to A, Q is equals to delta E plus W. Q, I think how much? 1900 you have calculated. That is equals to Delta E from D to A is 17,770 plus Deplave D to A. You will just calculate it now. So what is the value? Deplave D
minus
to A
15,870.
minus 15,870 kilojoules per minute. So this is the value of WDTA, which I'll be writing here. This minus how much?
15,870.
15,870. So make sure the values are correct because I don't have the calculator with me. So this is the problem, guys. Understood? Understood the problem?
Yes, sir.
Yes, sir.
So it's an easy problem where you apply the first law of thermodynamics in order to calculate the different values given in it. Okay, we shall look into another problem here. Okay, this is the problem given. Now, the gas undergoes a thermodynamic cycle consisting of following processes. So he has given three processes to us, and he is asking us to calculate rest of the things. Let us see what else those three processes are. Number one, number two, number three. Number one, Aditya, can you just read process 1 to 2?
Constant pressure P is equal to 1.51.
Just a minute.
1.41.
Okay, so where was I? Yes, this particular thing consists of three processes in it. This and this and this. So I think someone was reading the question, I guess. Who was that?
Yes, sir.
Ah, Aditya, yes, ma'am. So continue reading it.
Constant pressure P is equal to 1.4 bar.
Okay.
V1 is equal to 0.028 meter cube.
And
The
W1 to 2 is 10.5 kilojoules. So he is insisting that there are three different processes in this particular problem. So according to you, Aditya, process 1 to 2 is which process? Hmm? Anyone can answer this. Process 1 to 2 is assumed as which process? Just read the
Isobaric.
sentence. Isobaric. So that means the process should be, here it is indicated, see. The process 1, the process from 1 to 2 is an isobaric process like this. Okay. Next, the process 2, Aditya. That is from 2 to 3.
compression with PV is equal to C. U3 is equal to U2.
So just by looking at PV is equals to C, can you judge which process is this?
Polytropic.
Why polytropic? PV to the power of K is equals to constant. What is the value of K here?
Isothermal,
1.
sir. K equal to
Very
1.
good. So K is equals to 1. If K is equals to 1, that particular process is isothermal. So in an isothermal process, your temperature does not change. That's why your internal energy is a function of temperature alone. It depends only on the temperature. If you change the pressure, your internal energy will not change. If you change the volume, internal energy will not change. But only if you change the temperature, then only your internal energy changes. That's why if your temperature is constant, even your U3 value will be equal to U2 value. And that particular process is being represented as a curve in a PV diagram from process 2 to 3, where PV is equals to constant. Process number 3. Aditya.
Constant volume U1 minus U3 is equal to minus
So he has given
26.4.
that the difference between U1 minus and U3 is minus 26.4 kilojoules. We shall see how it would be used. And there is no significance change in the potential and kinetic energies that is specified. And the process 3 to 1 is a constant volume in the sense it should be a vertical line like this. Okay. So the parameters, whichever is being given, I have just indicated in the black color. The parameters which have already, which you need to calculate, that have indicated in the red color. So initially, the P1, V1 value would be given, P2, V2, and P3, V3 is given. Okay, it is 1.4 bar. P1 is equals to P2 because it is isobaric, and so on. Okay, calculate the heat transfer. Show that the cyclic integral of heat flows is equals to cyclic integral of work flows. That means he's asking us to prove the first law of thermodynamics applied for a cyclic process. Sketch the cycle on a PV diagram, which we have done just here. Okay, let us see how to solve this. Okay, W1 to 2 is given. Yes, W1 to 2 is given. You can observe here it is 10.5 kilojoules. So which process? W1 to 2 is which process? Isobaric. Second condition is given from 2 to 3. He says PV is equals to constant. So if PV is equals to constant, it implies that the value of K is 1. If K is equals to 1, then it is isothermal process. And as an isothermal process, your temperature would be constant. If your temperature is constant, since the internal energy is only dependent on temperature, the temperature is constant, therefore your internal energy is also constant. That is, U2 will be equal to U3 because it is isothermal process. Next condition is given, that is U1 minus U3 is minus 26.4. kilojoules that is given in the problem. That is because there is no change in interkinetic and potential energies. What we need to calculate is, we need to calculate what is Q1 to 2, sketch the on a PV diagrams. This we have done it already, and we have to state and prove that the cyclic integral of heat is equal to cyclic integral of work. That means we need to calculate Q1 to 2, Q2 to 3, Q3 to 1, and we have to calculate W1 to 2, W2 to 3, and W3 to 1. Ensure that summation of the values of Q is equals to the summation of values of W. So that is your ultimate goal. So for that, you need to calculate first all the workflows. Later, you will be calculating all the heat flows, and we will be comparing those two. Let us calculate one by one now. Calculation of all the workflows. First process is your isobaric process, where P is equals to V2 minus V1. See, this W is already given in the problem, which is 10.5 into 10 to the power of 3. P is given, V2 is not given, and V1 is given in the problem. So you can calculate what is the value of V2 and update it back in this particular state table here. Clear? Are you understanding, everyone?
Yes, sir.
Okay, fine.
Yes.
Okay, so the next process is W2 to 3, which is isothermal. The second form is being used here, P2 V2 into ln of V3 by V2. Since P3 is unknown, if you just look at the process 2 to 3, so this is the process 2 to 3. In this, initially, you will calculate P3 later, but P2, V2, and V3, only those were known, and P3 was not known. So since you have to use the PVT conversion equation for the process from 2 to 3, which is isothermal. The PVT conversion equation for the process 2 to 3, which is isothermal, is P2 V2 by T2 is equals to P3 V3 by T3. Since the temperature T2 and T3 are same, why? Because it is an isothermal process, you can cancel those. So P3 is equals to P2 divided by V3 by V2. By this, you can calculate the value of P3. Okay, that you can update it back here. Once the P3 value is calculated, I think there is no difficulty in calculating the value of work done from 2 to 3, which is isothermal. So it says P2 V2 into ln of V3 by V2. So just substitute the things and calculate the value of the work done from 2 to 3, which is isothermal. Now, what is the work done from 3 to 1? How do I calculate the work done from 3 to 1? Yes. How do I calculate the work done from 3 to 1? Is there any formula? What is the formula?
Zero, sir.
Why it is 0?
Isochoric process.
Very good. So that's why the work done from 3 to 1 is 0, because it is isochoric process. That is what I have written here. That's 0, just because it is isochoric. Now calculation of heat flows from all the processes. So you should have that screenshot with you whenever. See how to calculate the isobaric heat flow. You can just look into the screenshot and tell me how to calculate the isobaric heat flow. The first process heat flow. How do you calculate? How many of you have the screenshot of that particular thing? That teaching board.
P V2 minus V1.
Hmm?
P into V2 minus V1.
P into V2 minus V1 is the formula to calculate your workflow. What is the workflow? That if you want to calculate, you can use P into V2 minus V1. Now I want the heat flow. So in order to have the heat flow, I should have this particular thing. So how do I calculate the heat flow in case of isobaric process? I should take the difference between their enthalpies. The difference between their enthalpies gives the value of the heat flow for an isobaric process. Similarly, difference between the values of the internal energy will give you the value of heat flow for an isochoric process. Remember, for isobaric process, you have to calculate the difference in the enthalpy. For isochoric process, you must calculate the difference in the internal energy. So now it is isobaric process, so I should calculate the difference in the enthalpy here. Okay. So the same thing is being done here. So Q1 to since it is an isobaric process, change in enthalpy has to be calculated. That is equals to H2 minus H1. H2 is again U2 plus P2 V2, and H1 is again U1 plus P1 V1. Why? Because you have the value of H is equals to U plus PV. So this you have to remember again. Take the U's on the one side. Okay. So U2 minus U1 would be there here. So plus P2 V2 minus P1 V1. U2 can be written as U3 since you can go for the conditions here. So U2 is equals to U3 here. Okay, since why? Because it is an isothermal process, the internal energy at this point and this point would be same. The same thing I have used here, U2 is replaced as U3 minus of U1. Plus P2 V2 minus P1 V1. I think he has given this value U3 minus U1 in this particular case here. See, in the condition 3, he has given the value of U1 minus U3. Pick it from there and substitute the value. P2 V2 you know and P1 V1 you know. Just substitute. Thereby, you calculate the value of Q1 to 2, which is also bar. Now, how do I calculate the heat flow for the process 2 to 3, which is isothermal? How to calculate the heat flow? How to calculate the heat flow? Yes, guys, how do I calculate the heat flow for this? Look here, man. Where is that gone? For isothermal process, how do I calculate the heat flow?
By work done equation, same.
Same, right? So if you have your work done expression, the value of work done will be equal to the value of heat flow that is for the isothermal process. So just go back there. And so I have written here, so Q2 to 3 is equals to W2 to 3. W2 to 3, which you have already calculated, which is minus 18.78 kilojoules. So that will be equal to the value of Q2 to 3 because it is a thermal process. Now I want the value of heat flow for the process 3 to 1, which is isochoric. Now what is the value? How to calculate the heat flow for process 3 to 1, which is the isochoric. Yes. How do I do it? Look again to this. I want isochoric heat flow.
Difference between
Difference
internal and
between the internal energy, that is what is the heat flow. So same thing, I go back here to calculate the difference in the internal energy. Since it is from 3 to 1, so you can calculate U1 minus U3, that is the change in internal energy. U3 minus U1 is given as 26.24, which is given the problem. So U1 minus U3 would be negative of that. Just substitute the value and you'll get 3 to 1, which is isochoric, as this particular value. Now what you have to prove is the cyclic integral of Kiev is equal to cyclic integral of W. So add all the heat flows, add all the work flows, keep heat flows on the LHS, keep work flows on the RHS, substitute all the values and show that LHS is equals to RHS and write down and split. So that's your problem. Understood? Any problems, any doubts in this particular problem here? Any problem?
No, sir.
Understood the problems, both the problems?
Sir, once show the questions, sir.
Question. Yes, ma'am.
Yes, sir. Complete, sir.
Okay. Now, so after your internals, no, tomorrow there is a class, right? Take a screenshot of this problem. I want you to try this. This is the problem. Take a screenshot of this. Try this particular problem and know me if there are any difficulties in solving that. It's an easy problem, which is very much similar to the one which you have solved now. So when is your BTD internals? When?
30.
Oh, Monday.
Yes, sir.
Okay, Monday, which hour?
First,
First hour in the sense 11:15.
Yes, sir.
At 11:15 you have the
9:15.
exam? 9:15.
9:15, sir.
9:15.
9 to 11.
Okay, fine. Just give me the attendance, guys. So today the date is 25, right? Okay, Abdul Rahim,
Yes, sir.
Akash.
Present, sir.
Present, sir.
Okay.
Abdul Rahim present, sir.
Okay, just a minute. Okay, Abdul Rahim and Akash present for the page. Okay, Devgash,
Present, sir.
Harshit, Hashib,
Present, sir.
Hazi,
Present, sir.
Srijan Rai,
Present, sir.
Prem Kumar, Tishan Kotian, Lucky Sumanna,
Present, sir.
Latesh,
Yes, sir.
Mervin,
Present, sir.
Muhammad Khalid.
Present, sir. Sir, yesterday also present, sir. While left.
Okay, next is Munawar, Mohan Chandra,
Present, sir.
Muhammad Surei,
Present, sir.
Nishan.
Present, sir. Sir, yesterday also I was present, sir. I left early due to the battery loss.
Okay, next
Thank you,
is
sir.
Nitesh,
Present, sir.
Iman,
Present, sir.
Pradeep Shetty,
Present, sir.
Praveen Sudekant,
Present, sir.
Rai,
Present, sir.
Raj Prasad,
Present, sir.
Rajat,
Present, sir.
Rakesh, Ram Prasad. Sorry, Ram.
Present, sir. Present.
Okay. Ritik Lobu,
Present, sir.
Syed Anwar,
Present, sir.
Rohan.
Present, sir. Last class also present.
Okay. Sakesh Began,
Present, sir.
Saurabh Shetty,
Present, sir.
Srinivasan, Stephen,
Present, sir.
Sujan,
Present, sir.
Shan,
Present, sir. Present.
Vaibhav,
Present, sir.
Varun, Vignesh,
Present, sir.
Marvin Lance, Wayne,
Sir, Wayne. Sir, Marvin Lance, present, sir.
Swaroop.
Hello, sir.
Yes, Mark Monday.
Present, sir.
Thank you, sir. Wayne, present, sir.
Kiran,
So present, sir. Sir, and I was yesterday class, previous class also.
okay, Mendan, Mendan Karthik, Tarsana Shetty, Anish Pinto,
Present, sir.
Kat J, Praveen Nair, Abdul San,
Present, sir. Last class was present, sir.
okay, Aditya Shetty,
Present, sir.
Amal PK,
Present, sir.
Chandan Rao P, Amok P Hegde,
Present, sir.
okay, Chandan Rao, Chirayu,
Present, sir.
Cyril Vikas,
Present, sir.
Darshan Shetty, Vitlaj,
Present, sir.
Narendra Naik, Umar Seidan,
Present,
Siddhant
sir.
Casey,
Yes, sir. Present, sir.
Rachana Shetty,
Present, sir.
Ritesh Kumar,
Sir. Sir, present, sir.
Raj, Muhammad Khalil.
Thank you, sir.
Okay, pa. Thank you. We shall meet in the next class, tomorrow's class. Okay.
Sir, Prakya, present, sir. Sir,
Sir, Praveen Nair is present, sir.
sir, Prakya, present, sir. Sir, Wayne, present, sir.
We have marked here. Prakhya.
Sir.
Sir, Prakya.
Yes, yes, yes. 1 minute. Prakhya have marked here.
Thank you, sir.
Praveen Nair
Yes, sir, present.
have marked here. Darshan Shetty.
Sir. Sir.
Darshan Shetty have marked here. Yes.
Sir, can you show
Karthik, sir. Mendan.
Okay. Yes, Anish.
Sir, can you show the first problem?
Nav, I have just closed my iPad. Can I show it tomorrow? During tomorrow's class?
Okay, sir.
Okay, pa.
Okay.
Yeah.
Mendan Karthik also present, sir.
Where he is?
He got the network problem. He just called me.
Ask him to call me.
Okay.
Okay.